Getting ready for the first tweet?
Sorry?
Getting ready. I'm on. Okay, welcome to Dialogue 17 and to Elsinore. There are 102 of us this year. Really nice number. I like to see this room filled up with people. This hum that goes on immediately when you arrive, start talking to each other. There's a couple of new countries. Well, we've had people from Belgium before, but this time 4 of them. Welcome to Dialogue user meeting. And 2 from Japan. A very warm, heartfelt welcome to you too. And if you wonder why the United States is on the top of the graph and at the bottom of the table, I spent an hour yesterday trying to get Microsoft to do it in the right order, but for some reason they think they want to turn it upside down. So, yeah. I even tried to sort them after number of participants, but then they also turned the thing upside down on the graph, so I mean it didn't help. But I would like to point out that Denmark this year has the largest number of participants. That's never happened before, even if we had the conference in Denmark. Welcome to all the Danes. Okay, so I promised to talk a little bit about Troels Kirk. The banner on the website about the conference is about this cut of this original artwork. A couple of years ago, we at Insight Systems, who are one of the owners of Dyalog, sponsored a painting done by this local artist, and he spent like at least a week out here in a little dinghy trying to get the picture of the city in the morning light exactly right. And this is on midsummer morning, where he's getting all the light completely right on the facades of the city. I mean, obviously Elsinore is not such a big city that its skyline is available online, but this picture actually gives it to you. So let me just, when you get the slides, you might want to visit his website. He's a very, very good natural painter. It's a picture of a seagull on a, I mean, you would think that that's actually a photograph, but it's not. It's painted, and his latest project is this one, 2 Swedish horses, work horses, and if you look down here, you'll see the size of the painting. It's actual size. He's painted 2 horses in natural size. There's a little movie there on that project, and I mean, the creative process of an artist is very much like the programming. You go there, you research, like he's in that dinghy outside Elsinore to get it exactly right, the specs for his painting, and then he spends a long time manifesting what he's researched. Same thing with these horses, photographing them, drawing them, and then providing this painting. So I just thought I'd show you. He's very graciously allowed us to use the painting and even cut it for our banners. Okay, so enough about that. The Dialog staff, there is 21 of us here. Could you please all raise? Oh, and they even almost all of them got the right shirt on. Now, to all of you delegates, take this opportunity to talk to the Dialog staff. Tell them about what you've been doing, what you're needing, what you want to see, this is why they're here, to meet with you and to take your input and to help you if there's questions or problems that you have. So that means that there's only one of us left in Bramley. That's Vince. He's manning the fort, taking the phone, answering the emails for the few of you that are not here. And he is probably the one who talks to most of you on a day-to-day basis. So he'll survive being at home. And last year we announced that we were aiming to hire 2 more people, and we did. And that's Marshall Lockbrown. He's an interpreter developer, and he's stationed in Bramley. He's joining Dyalog with a big reputation from the J community, so he's already a famous person in the array language community. Marshall, can you please get up? I saw, yeah, there you are. So everybody, take the chance to get to know him. And the other person we hired is Michael Bass, who's been a very long time user of Dyalog APL, and he will be staying in Germany where he lives, but he's working with the tool groups, spending quite some time in Bramley, but also on the Skype or appear in, talking to the other guys from the tools group. Yes. Unfortunately, we also lost 2. We already warned you last year that Nick Nikolov he's now back in Bulgaria, but still active in APL. Morten will give you an example of that a little bit later. And then sadly, just after the conference last year, Dan Barony went for a 4-month holiday, you could say, but he actually didn't make it very far. So he died in a motorcycle accident on the 1st of November. He is sorely missed. If this is the first you know of it, you might want to visit his memorial page, where there are some really nice memories of Dan. And maybe you want to contribute. So, what's Dyalog been up to in the year past? More of the same. There is a big change in the technological environment right now, and that is, in fact, the hardest work we have to do, always keep APL up to date in terms of the environment, so that it's easy for you to work with other elements of the corporate environment or other people's nice pieces of code. And so that's just something we need to do, and once we are done, Microsoft or somebody else will turn the whole thing upside down again, and we'll have to start from the bottom again. But we also do get to, in between all this other stuff, put in some of the elegant stuff that we really like to do, and that makes the expressive power of APL better. So, with version 16, we have a lot of the stones rolling up the mountain. There's the usual performance enhancements. We always do that. We got some quad JSON. We had a lot of I-beams before. This is a way to exchange data with the environment, and particularly in the web environment. Write for a cross-platform development environment, so that you can actually develop on Linuxes and Macs and whatever platform we are going to provide you with in the future. We have an embedded HTML rendering. That means that you can create GUI that's transportable from Windows to Linux to Mac, which should be a good thing for the future. Some generic data binding. We're not completely there with the data binding yet. We still need a bit more in the HTML Java environment. or JavaScript. We got a beautiful little quad comma-separated variable thing for high-performance import and export of textual data, or structured textual data. And we got some lovely new primitive operators, the elegant, the at, the stencil, and some enhancements to IOTA and member of. That'll all be explained to you a bit later. But I actually think we could call the quad CSV for one of the elegant things. It's really nice. So what will we be up to? Yeah, we believe that version 16 is actually a very important step towards adapting APL to the new environment that's emerging. The first step to a tool chain that'll help you develop distributed application in this environment, like web services, web servers, web services, and even cloud applications. This is the future. It's not completely there yet, but I mean, it is where you probably are headed in the future, unless somebody turns it all upside down. We've just renewed the license for Syncfusion. It's a widget library. When we did it 4 years ago, we thought it would be the WPF part of their libraries that would be important. Fortunately, they also have JavaScript libraries, so and they have really built that out and enhanced that. They also have some more application block things, and we've got the right to all of it. So if you're looking to supply dashboard to your applications, or you are looking at new report engines, I think there's a new standard coming up all over the world for financial reporting. They actually have building blocks for that. So go and have a look and see what they're offering today. And if you start using it, let us know. We are there to help you, and I mean, all of these widgets need some wrapping to be easily called from APL, but it's only your usage of it that can guide us to which ones we should start by providing in a nicely packaged way. We have introduced a new multi-platform developer license. Actually, it means we've sold one of them. It will appear on our price list shortly. Because one guy called us, and now usually it was people calling us saying, well, I have a home computer and I have a work computer. Can I use Dyalog on both of these? Yes, you can, unless you're using them both at the same time. So it means if you're one person and you're at one place, you can use your license at the machine at that place. Now this guy called us and said, now I have a Mac and a Windows machine. I'd like to use my Dyalog on both of them. Obvious, a natural thing. So you do need access to all of them. Up until now, it's been the royalty license holders that has had that access, but there's no reason with the tool chains and with the future we see that all of our developer licenses should not cover that. So we have created that, and you'll see it on the price list shortly. This is a slide from 2015, where I announced some more evangelism. Things always takes longer than you think, but so last year I had to apologize. This year I don't have to apologize. We are actually starting to ramp up for this. We've added more resources to the tool group to be able to produce more of these examples and templates that we are going to need, both for our current users, but also for the new people who are going to arrive. And we finally got started producing some live content, apart from the streaming from the user meeting. And it's currently once a month, but I think we plan to raise the frequency of that. And also, we have a plan to make a full educational program for Dyalog APL as a set of videos that we can also man so that people can do tasks and talk to a tutor after having watched each section of the videos. And we are taking summer interns in Dyalog. First off, why does that connect to this? I'll get back to that. But let me introduce this year's winners of the contest. It's just because it's almost the last day we get to hear how they solve the contest, but people want to talk to them during the conference. So is Kostas here? No, he's sleeping. Okay. He's probably preparing for this afternoon where he's going to give us an extra talk about how he's been working with APL during his work in physics at the University of Patras. But he looks like that, so after his first presentation this afternoon, you might be able to talk to him. Okay. We're starting to, well, I was almost tempted to say generate the next generation of APLers, the people who are going to take you into the next 50 years. Well, at our own side, we have Adam, who's joined us. He fell in the pot as a kid. His father taught him APL when he was a little more than a toddler. So he's very enthusiastic about APL and designing the language to his liking. He'll meet some resistance sometimes. He's also a fierce code golf evangelist, so he's attracting a lot of other young people on these code golf sites where they battle on the shortest expression to solve a problem. And we've got Marshall, who just spoke about before, implementing on the interpreter team. Especially, he's extremely good at optimizing code mechanisms internally to the interpreter. And I think when Morten shows you the prospect for performance enhancements for the next release, you'll be really surprised. And we got Aaron Su. Where is he? Also preparing for his talk. You will get to see him do part of his evangelism shortly. It's the last talk before lunch. He's done some really serious good work on APL and promoting APL on various fora and at various conferences for particularly functional programming. Then we have started to see the benefit of the contests, the competitions. We've had one of the winners from last year, Marinus Ustas, has spent 6 weeks with us this year at Dyalog, and during that time he's built a Python bridge and done an APL secure socket, whatever it is, thingy, secure shell. That's pretty good work for a newcomer. He's very fast and very bright. We have here Zach Batik, who won also last year. We had 3 winners last year because it was 50th anniversary of APL. And he's done the contest for us this year. And we've had actually quite a lot of competitors this year, much more than we are used to. So I don't know if it's the problem or the marketing that's attracting people. And you might recall Ronald Chan, the first winner of the competition. He did a matrix inverse for us as an intern, and also the R interface. He did that over Christmas while in our house, 500 meters down the road. And I'd also like to mention people like Callum and Jill from Optima. They are currently helping us. You know, Nick left and he was the right author, so they have taken over that work. and they brought right a good step forward in terms of catching up with the old IDE. So, yeah, before I hand you over to Morten, I'll hand you over to another young APLer who you might recall a couple of years ago were running around and was termed the blind mice together with two of his colleagues by Paul Groner. Sam has grown out of that role, believe me. He's a real workforce at Optima now, and he is helping us promote APL. So he's the master behind the APL Code Golf Challenge this year. So please play along with what he's going to present to you and enjoy the user meeting. I promised Jason that I would say this year when you ask questions, there's a mic, there's going to be a mic over there, and this is how we are going to do it. A line at the mic, and that means that you'll both be on camera and on audio, and we don't have to cut the questions out of our videos. Okay? Okay?
Can you hear me? Yep. Good. Right, so I'm Sam Gutzel. I'm from Optima Systems in the UK, and I'm here today to introduce the first ever APL Code Golf tournament. So, the tournament. You can find the details on the flyers that are given out in your goodie bags this year. If you haven't seen it already, there is also a roller banner placed by the registration desk. So you should be able to scan the QR code or just type in the email address directly and be able to sign up. You can also find the rules under the rules section on the website, so you'll be able to see what is and isn't allowed. So how to play. So to participate, you need to sign up at the website I've mentioned already. You can see the login form up there. You will be given a unique login code, so it will be emailed to you, and in case you lose track, you can find it under your account. So keep hold of that just in case you need to log in again. So the holes. The hole design is you will progress one by one. It's a tabbed format, so you can see up there. You can choose quad ML and quad IO per solution. So when you have your answer, you can put your own solution into the box there and check solution. It will submit your answer. It's not just for fun. There are some prizes, so you can look forward to that if you're very good at code golf. The first place prize is a 4K video camera with a 32GB SD card. The second prize, don't sway while you're presenting. That's a tip for anyone doing it. The second prize isn't actually second place. It's a special award, so whoever gives us an intriguing answer or something that really makes us think about how we do things in APL. So it's more of a special award rather than a second place prize. But that's a 1080p camera with a 32GB SD card. The prizes will be given out at the banquet on Wednesday, so you can play along if you're not at the conference, but you won't be receiving any prizes. So the team, this is the team that's here on site this week. You can see us all up there. Don't know if you all want to stand up and show your faces. So take a look around. If you have any questions, please come and approach us, and we'll try our best to try and give you an answer to your questions and queries. We might not always be able to answer you, but I'm sure we'll be able to give you one eventually. I have to give a special thanks to Callum as well, because he's built the entire technical stack from start to finish, the APL backend all the way up to the front end. So thank you for that. And I hope you have a good time taking part, and please, like I said, let us know if you have any problems, and happy golfing.
not going to. We'll show that later. Oops. Glasses. I never get used to it. I've needed them for 5 years, but I'm still pretending I don't. Let's see. Here we go. Oops. That was the end. I love this room. Welcome again, and especially to those of you who are not coming again, but coming for the first time. It's really good to see you. So, I'm used to following Gitta up after Gitta in this room. It's been several times, but I'm still getting used to this. I'm the Experience Officer. It's only the second time I'm doing the talk with that title, but I am really starting to enjoy it. I've complained the last several years that really the roadmap doesn't change. But there, as Gitta mentioned, there are things, there's a bit of a sea change. So I'm not changing my form of evangelism. This is still about Dyalog APL, because cloud computing is really about to break loose. I mean, how many people are already deploying stuff on the cloud in one form or planning to do it really soon? Yeah. So this is something, if you haven't looked at it, you need to start reading about it and looking at what we're doing to support it. The good news is that the roadmap really still hasn't changed, because most of the things that we're doing, this is a slide from Dialogue 14. I think the word cloud appears in our keynote presentations for the first time, probably 3 or 4 years before that. So the work that we're doing in particular on going cross-platform and parallel processing, launching remote processes and managing them from APL, stuff that we've been working on for years, is all really just ready to roll out on the cloud. For example, one of the things you could really take advantage of on the cloud is going parallel. The isolates, how many people are using isolates? That's very disappointing. That's really disappointing. I thought this was the bee's knees, and everybody would be using it. It's been there for 5 years now. Maybe the cloud is going to make it much more interesting, because this is another slide from the regular isolate presentation, and it shows how you can start isolates, and if you have another computer, you can harness that, and of course the other computer could just be a virtual machine in the cloud, or 100 virtual machines in the cloud that you spin up just for 5 minutes to do some computation before moving on. Of course, parallel is good. It requires some work, though, and most of you probably just hoping that we'll make everything go incredibly fast. And there also, for many years now, we've been working very steadily towards improving the performance release by release. That was really the really good one. But they're all pretty good. And I don't know whether the 3/5 there is accurate in terms of how many more ideas Marshall and Roger and other people have to go into version 17, but it also looks like it's going to be very good. And one of the really important things about the cloud is that your ultimate cost is in many ways just going to be measured in watts, because you're paying for a data center up in the forests of Finland where it's been placed to be cheap to cool, or on Iceland where they can use geothermal power to drive it. But you're really paying for the CPU and the memory consumption. And memory is actually one of the areas where APL also does really well. If you design your applications well in APL using bit booleans or 1-byte integers, you can really have a dramatically smaller memory footprint for big data analysis than you would have if you were using typical object-oriented technologies, although they're realizing this stuff and catching up. But we have a huge head start there. So the text up in the top corner is a little bit provocative, and the Microsoft fans will probably be shaking their heads. But if you look at, and I'm not in any way suggesting that Microsoft isn't going to be a major player in the cloud, But what you'll see if you look at what Microsoft is doing on the cloud is that they're producing very cut down, trimmed versions of their operating systems, which from an application building perspective look more and more like Unix's. So the work that we're doing to support Unix is going to be beneficial also for the people who stay with Microsoft for the long term. Linux, though, is currently sort of a bit ahead because it typically uses less memory and therefore is cheaper, and of course the licenses are cheaper. And we're really working hard. We have this mantra that you should be able to develop an APL application on any one of our platforms and without converting the code. Did I talk for too long? Jason? Okay. I have to talk less on each slide. Yeah. But Richard, for example, has been doing very hard work on cross-platform file functions, so you can deal with files and folders and so on in exactly the same way on all platforms. He has a talk this year as well on extensions to that. One of the big challenges, of course, going cross-platform is you need to be able to develop and debug code on all the different platforms. And this isn't the earliest slide. The earliest version of RIDE, I think, is 2 or 3 years before that, when we had a Silverlight version. But RIDE has really come a long way, and now, thanks to the efforts of Gil and Callum, is really reaching. If you look at the screenshot here of version 4, we can argue about the coloring of the icons and stuff like that. But the functionality of the Windows IDE, the most important functionality, including things like the Threads window and the Stack window and the Workspace Explorer, all the things that I think people find really important when debugging applications, are becoming available on all platforms. So you can have your virtual machine on the cloud, and you can connect RIDE to it and do development there. Now, of course, as the weather changes, we're going to need some young people on deck to help us weather the storms and work hard. And managers, of course. We need to make APL attractive to new generations, not just the developers, but also their bosses. And that's something that I don't feel I spoke for too long there on that slide. Okay, so what do these people need? Well, let's look at the managers first. The biggest problem, I think, is to be able to recruit and train APLers, to feel confident that if your project suddenly grows, we have the cloud now, so you can quickly ramp up your hardware, or you don't have to ramp up your hardware, you have virtual hardware, but ramping up your development team is still something where I think managers don't feel completely confident. And that's where the evangelism work, getting out there, functional and other dynamic language conferences, spreading the word of APL, getting a new generation of developers to consider APL an interesting language to learn so that they'll be available is very important. Managers really feel it's important to be able to use industry standard tools, methodologies. They're all getting into agile now. They want to do continuous deployment. They want to use Git. They want test-driven development and so on. And these are things that we really need to work hard on in the next years to make them feel comfortable. We're making good progress, but there's a way to go. And I'm going to do a presentation after lunch on this. This is perhaps one of the key aspects at the moment, or the first one that Dyalog really needs to provide industrial strength solutions for, is APL source code in text files. We're nearly there, but there's still work to do. Because that allows people to use third-party tools. This is something called SourceTree that we use. I think nearly everybody in the APL tools group is using SourceTree. It's connected to GitHub, so it's providing a graph of all the branches and tracking all the commits that have been made by Marinus, Jay, and myself. And because the APL code is in text files, it's able to diff the code in exactly and provide information about differences and so on. Incremental updates to the code database in exactly the same way that it would do for JavaScript or C# and so on. And that's really critical. So if you're not already heading in this direction, you might want to consider it. What do the newbies need? Well, it turns out they sort of need pretty much, they certainly start in the same place as these managers. Of course, they need to be recruited rather than be doing the recruiting. But they already know how to use these methodologies. They've just been trained in them, and they expect an APL shop to be doing state-of-the-art software development, of course, using the methodologies that they're accustomed to. Now, all of us, whether we're new or old, need a modern set of libraries to build our applications on. And the demands of the new platforms, we need to encrypt our data, everything needs to be secure, we need to use internet protocols like JSON and XML to transfer the data. The demands of these new platforms mean that creating new libraries and sharing them is more important than it's ever been before. And the libraries need to be easy to find. You need to be able to share. Ideally, many of you will contribute to them. And we believe GitHub is a good place to start. Now, I know, apparently, some people are intimidated by GitHub. How many people feel intimidated by GitHub? Okay. So don't panic. All the libraries, all the source code that we put into GitHub that we feel is important for your applications, we will also include with Dyalog installations. So you can use GitHub if you like it. Apparently there are a whole bunch of people who do like it. If you want to see all the changes, like you saw on that list there, you know, who committed what last week, what's Dyalog actually working on, you can go to GitHub and you can see charts and things, how many commits we're making. And if you want to contribute, though, of course, if you really want to zip it up and send it in an email to somebody at Dyalog and let us put it in the repository, that'll be okay. So what is GitHub? It's a web-based source code management. So there's a tool called Git, which is perhaps the most widely used source code management system today. GitHub is a web-hosted version of that. You can have private stuff there. You can optionally make it public, accept contributions. So if that sounds really scary still, close your eyes for the next minute or so. But if you really want to help us reach the new generation of users, managers, and developers, you might want to keep them open. So I've browsed to Dyalog library Conga on GitHub, which is where the APL code that surrounds the Conga DLLs. These are utilities to use them. So you can see there's 3 files here. There's FTP client, HTTP command, and HTTP utils, which is some APL code that helps you use our TCP library, essentially. If you're not comfortable going there to get it, these are things that we consider really important. So in the main version 16 folder, below the Dyalog folder, there's something called library, and below library there's something called core and something called Conga. And those 3 files are there. If you want to load them in and use them in your APL application or interactively, the SALT working directories are set up so that everything in library will just be loaded, same as WSPath for the workspaces. And you can load it and you can check whether the Great Large Hadron Collider has destroyed the world by doing an HTTP command get on this URL, which returns some XML data, which you pass through quad XML, which gives you a matrix where the second column is the tags and the third column is the data content. You can pass that to a little defun where you extract the content tag, and the value is nope, which is very good to know. This, you can't read this, it's just the 25 repositories that Dyalog, the 25 public repositories that Dyalog currently has on GitHub. Have a browse. Okay. If anybody's sitting next to you with their eyes closed, you please poke them so they come back. All right, and of course, we need to make it easier to learn APL. Try APL is now, how many years is that, Brian? 5.5. So again, this was one of the it was a programming contest winner, Joel Huff, who in his presentation, I can't remember where it was, Boston, yeah. He said, well, the first thing I do when I want to learn a language is I go http://try nameoflanguage.org. And there wasn't one. And I was sitting in the front row and I pigeoned Brian and I said, we got to have one of these. And he's done a great job. This is now really attracting, I think we have something like 30 or 40 users a day using this. I think John gave a whole evening lecture workshop where all of the participants were just using Try APL as an interactive. He didn't have to install anything. They were just typing away on Try APL. Adam has found this thing, Try It Online, through his code golfing friends, I presume. This is something that it supports 343 languages. If you type APL into the search box, you can see that we're not the only game in town. Nikolov is out there. He's got it. Oh, I don't know whether Adam did that or Nick did it, but I presume Nick did. And this is different from Try APL. Try APL is very sandboxed. It wants to make sure you can't destroy, you can't type _h, rm, star, or -r. The Try It Online allows you to run anything at all, and it runs it in a virtual machine sandbox, which as soon as it's finished running it, it just destroys it and builds a new one. So you can, put classes in, and you can do anything you want. We're working on the cookbook, I think. Again, unfortunately, that's something you've heard about for 2 or 3 years without it being completed. But it's now moving ahead quite well, and I think early next year we're going to be able to publish the first complete APL cookbook. So that's a book written by Stephen Taylor and Kai Jäger with a bit of input from us. And it takes you from the point where you become comfortable with APL as a mathematical notation, and maybe you've written some cool algorithms, and you need to ship them as a product. So you need logging and configuration files, and you need to create standalone executables, you need online help and all of that stuff. So it's the cookbook for turning your various ingredients into something edible. Gita mentioned the webinars. That's something I'm really happy that we set ourselves the target of doing one a month. For 4 months in a row, we've been able to do that. Here's a picture from the last one. It's in our boardroom. Jason's started playing with this green screen technology so that we float in front of our APL sessions. We can walk around in our APL sessions if we want. This is our 2 summer interns, Becca and Stephanie, who did a robot show. All of this stuff is recorded. If you missed it, go to Dyalog TV and you can see it all again. If you haven't been introduced, which year are we on now, Gita, of ships? We had worms.
Yeah,
7 worms. This is the 13th.
Yeah, but we had a worm before.
We had a worm before, okay. So we're on to ships now for the regular user meetings. The webinars have Odin's ravens, Hugin and Munin, as the symbols, because the legend or the story is Odin sent them out into the world each morning. They flew around the world, and then they returned at the end of the day, and they sat on his shoulder, and they told him what was happening in the world. So that's why we felt they were appropriate for the webinars. There isn't one this coming Thursday, but this is just to show you that generally we run them mid-afternoon in the UK, And in the ones we've run so far, we've had people actually east of Bangalore. I think we had people in Japan, and we've had people in San Francisco. I think we had somebody in Hawaii, but they must have been up at stupid o'clock. But most people should be able to follow them without having to be up in the middle of the night. So far we've done 4 webinars. I'm not going to read that aloud. You can watch them live. Their recordings are generally available immediately. I think you can arrive half an hour late and start watching it. So we haven't decided what to do. I think this date will work. I haven't actually asked anybody else at Dyalog whether that's going to be okay. But you have a few days now to suggest webinar topics. It would be very useful to us to know what you would like us to spend an hour demonstrating to you. Now, although this is the 13th time I do this, I do have one demo. I'm going to dare to do one demo. The latest weapon for teaching APL that's just been added to our arsenal, I think not even everybody at Dyalog has seen this yet, it just arrived, is something called Jupyter Notebooks. The Jupyter Notebooks are a technology that allow you to mix what's called Markdown, so you can format text with titles and links and fonts and colors and so on, with expressions that are executed in a programming language. So here's a little introduction to Sharpplot that I started putting together. It doesn't yet teach you very much about Sharpplot. But you can see that we have a section of Markdown where I can write text, format it nicely. I haven't really worked very hard on that. I think if I double click on this, it turns into edit mode and I can edit the Markdown. But if I was a user, I would come to this, I would just click on play, and it moves down. Uh-oh. All right, just a second. Decided to shut down on the way from my room to here. So it's based on Python, the py in Jupyter. There we go, Jupyter Notebook. With a bit of luck, that'll come back to life. Oh, yeah, see, it launched an APL in the background. It's still using a development system, so you can see it, but of course, well, actually, it may have to be a development system. So what this is also is another example of how valuable it's going to be that the RIDE protocol is open and JSON-based now, because we outsourced this work to a technology partner in Belgrade. A bunch of people we've been working with, they've also worked on the HTML renderer, and they were able to put this together in a few weeks without us saying more than, here's the RIDE protocol. Here's the specification for Jupyter Notebooks. Please give us a Jupyter Notebook kernel for Dyalog APL. Yep, so we step through the tutorial. I need to define a little IBeam. RIDE has, if you're using RIDE, there's a little IBeam called 3500 IBeam, which if you pass it some HTML, it pops up a window and renders that. So if you have graphics or anything, you can get that to pop up. And the Jupyter Notebook code intercepts that message. So when we get down to this line here, where we say run Adrian's samples.sample, render it as an SVG file in fixed aspect ratio, and then pass it to the IBeam, we'll probably make this a bit slicker for the Jupyter Notebook, so you don't have to do that. You can have graphical output. So if your application, if you write APL code that generates HTML or SVG or anything like that, we can have APL notebooks containing a mixture of APL code, text that gets output. And it's interactive. So when we get down here, I've just added some outer product. So if I go and edit that, I can say APL supports Cartesian products. Maybe that's not technically exactly correct. And then resume running. It runs that expression. The user can say, well, that's very interesting, but actually I want to do it from 3 up to 10. Hit Shift-Enter, and interactively re-execute pieces of this. So we think this is really promising as a way to publish APL tutorials in the future. I think it's what's used now generally by most people who are using Python or modern languages to show how their libraries work and so on. It's really exciting stuff. All right, so please join us when you get a copy of this, which will be very soon, and start creating notebooks. This will require that you have Dyalog APL installed and Python installed. I think we need to work fairly quickly, where's Jason and Brian, on finding a way to use something like TryAPL Engine to host the session so that people don't have to install anything. We'll use the cloud for that. It should be easy. Okay, so what next? Well, obviously, the same old performance, documentation, quality. I think this is perhaps the most important thing from my perspective for version 17 is really going to industrial strength on the support for APL source code. There's a talk by Adam, I think tomorrow, on a notation for array constants, because one of the things you're going to need, if everything becomes text-based, is a way to represent arrays, the constants in your program, multidimensional arrays, nested arrays, literally in the source code. We need tools to build workspaces and other runtime. I think they call them artifacts in the continuous deployment terminology from the source. We have a bunch of new libraries to work on, HTML generation. It's time to move on from COM and be able to create Excel files, not just on Windows, also on other platforms. And for the time where Windows has really been the most important platform for APL applications, we've had really good integration with first DDE and then COM and then .NET. We don't have a good story yet on other platforms for integration. So we need a way to package your APL system as a shared library, and we need to support APL as a scripting language, hashbang style, if any of you are young enough to know what that means. Way of calling one scripting language, or Jeff, that includes Jeff. Yes, sorry. Yeah, I have to be careful with words here, terminology. When I really get into dreaming about what I'd like to see, I think, I'd like a startup switch, so you start Dyalog and out of the box without any additional source code, no salt, no my server, it just runs as a web service and starts serving up my little workspace containing foo and goo as a web service. I'd like to see the HTML renderer integrated with RIDE so that you can run an application on the cloud as a personal user, start an application, and without running Apache or IIS or any web server, just have a rich user interface rendered on your Android device. I think to take advantage of the cloud, we really need this cross-platform tools to launch remote processes very, very easily from APL, so you can just spin up processes on the cloud or on other machines that are available to you. And then we'll be able to have portable applications, desktops, mobile, cloud, regardless of whether the user interface is rich or simple, or there's no user interface at all. And you can build both personal or corporate applications and have APL running everywhere, on things as well. Version 16 was a really good step in this direction. Some of the technologies are still a bit fresh, but I'm totally convinced that they are all steps in the right direction for supporting the cloud and attracting that next generation of developers and managers. And the evangelism is ramping up. It's not just the kids, and it's not just in Bangalore, it's now also in Dublin. John has been talking to functional programmers in Dublin at a meetup regularly, and they're quite enthusiastic, I believe. Yeah? They love it. And the Indian functional programmers love it. So we've been to Functional Conf, I think 3 years. We're going again this year. I'm going. Aaron's been invited separately. Roger is coming along as well this year. Here's Roger doing a talk in Bangalore recently, talking about selfies. And Aaron is going to be repeating a bit of the talk that I saw him see in Boulder, Colorado at something called LambdaConf, which is another functional. We're at the moment, we're going to a lot of functional events because it's easy to sell APL to functional people. They get it. It's like they think APL is this modern thing that was just invented as a branch of functional programming. It seems familiar to them. And Aaron's talk, which I'm really looking forward to just before lunch, was his introduction, or I don't know exactly what Aaron's going to do, but it's, I'm assuming it's something similar to what you did there, where you really talked about the differences between the mindset of traditional programming and APL. Yeah. And Adam with the Code Golf, I think Marinos came to us through Code Golf, is that correct? This is really starting to have an impact. And instead of quotes from Functional Conf, I have some quotes from code golfers that who've been, watching Adam, and an increasing number of people submit things in APL, or even if they can't submit it, I don't have an APL interpreter, but I still upvote them because they're awesome. And I really like this one. APL has a lot of specific built-ins, but they're also versatile. And I like to, go to dynamic language conferences and say, well, APL is general purpose domain-specific notation. And now, Jay is going to tell us how it all is all going to come true, hopefully. Thank you.
No time for questions?
Oh, questions. No time for questions. Where did your presentation go?
CTO roadmap. Hello, can you hear me? Hi, to those of you who don't know me, I'm Jay Fode, the CTO of Dyalog. And I'm going to talk a bit more about the low-level details. I'm going to do a run-through of some of the features in version 16 of Dyalog, which was released this summer. Then I'll talk a little bit about what features might be in the next release, and something about the other things that we're doing, as well as just implementing Dyalog APL. So version 16, Morten and Geeta have both mentioned a bit of this. Hopefully, quite a few of you will already have downloaded version 16 and will be using it, and will know some of this. A lot of you, I guess, also went to the workshop yesterday. So if there's some repetition here, I apologize. But I'm going to take a brief tour of what went into version 16 and why. Version 16, in particular, had quite a few new language primitives, starting with the @ operator, which is trying to help move the language in a slightly more functional direction. It's giving you a way of modifying arrays, which traditionally in APL would have been done with indexed assignment or selective assignment. The problem with those is that they don't compose well into simple functional expressions. They force you to name the array that you're going to modify, and you can't use them as part of a larger expression easily. So at is supposed to be a very intuitive way of saying, I'd like to take some array modified in some way. For example, I'd like to put an asterisk at positions 2 and 4 in that vector. And you can kind of read this, you can read it the way it's written. Stars at 2, 4 in hello. As well as just replacing items, you can perform modifications to certain items. So if you start with a 3x3 numeric array, you can say tenfold at, and in this case, instead of specifying the positions I want to modify explicitly, I've written a little function which says every even number, everywhere where the 2 residue of the item is 0, I want to multiply by 10. So there's 3 reshaped by iota 9, but with all the even numbers multiplied by 10. The next new primitive is the stencil operator. This, I think, grew out of long-standing discussions about the cut operator that used to be in Sharp APL and, I guess, in J, which did many things. Stencil is a bit more of a specialized operator. It's used for doing what the scientific and mathematical community calls stencil computations or kernel codes, which are used a lot in things like image processing, where you want to apply a filter over small regions of an image. For example, it takes an arbitrary array, here I've shown it with a matrix of characters, and applies some function to rectangular windows centered around each item of that array in turn. And there are some slightly simpler, but no less useful new primitives. Monadic enclose underbar is something that I think we've mentioned for the last year or two. We used to refer to it as enclose if simple. It's a kind of convenience for application programmers if you're writing a function that takes a bunch of strings as input, but occasionally you're given just one string, and because of the way APL works, it's easy to get confused in that case. If you're given a single string foo, it kind of looks like a vector of 3 things, whereas you'd like to say, actually, I've got a list of arguments, but there is only one argument, which is this string. So enclose if simple will take either of these inputs and make sure that what you get back is a nested vector of vectors, or a nested array of vectors. So in this case, you started out with a nested array. It returns the argument unchanged. In this case, because the argument is simple, it will enclose it for you. So you're guaranteed that what you get back is nested, i.e. has depth, at least 2. And the dyadic case of the same character is a way of... Dyalog has had quad ML since, I don't know, pretty much since day 1, which is a way of tweaking the language dialect to more closely match APL2 or to more closely match the sort of core APL language. And we've been gently trying to nudge people in the direction of standardizing on quad ML1, which is the kind of dialogue flavor of the language. And in order to make that easier for users, one of the things that you couldn't easily get at in quad ML1 is the APL2 partition primitive. So we've introduced dyadic left two underbar as a way of getting at the APL2 partition primitive without having to go to the trouble of localizing quad ML just to get that functionality. And 2 more primitives. Monadic iota underbar is a very simple function called where, which will, given a Boolean array, will tell you where the ones are in that array. You can write it in a few characters as a defin. You can write omega, replicate iota row omega, but it turned out to be so pervasive that we think it's worth introducing it as a primitive. I was personally surprised by that. I thought people knew how to write it as 5 characters, and that was good enough, but it seems to have got a lot of support from general application programmers. And the dyadic case of iota underbar is a new function called interval index, which is Roger's invention. I guess it comes from J again, which is, it is in some ways similar to dyadic iota in that it will look up the items of the right argument in the left argument, but rather than looking for exact matches, it uses the left argument to create a series of intervals. So notionally, from -infinity to infinity, there are these intervals where the items I've specified on the left-hand side tell you the starting point of each of these intervals. So for example, all characters from A up to just before E form a particular interval. Then for each character in the right argument, it will look up into which of these intervals it falls and return you the corresponding index. This has been designed very nicely to work well with the key operator. So if you're used to using key for grouping values that have identical keys, this gives you a very slick way of grouping items which have keys that fall into particular ranges instead of having to have an exact match. As well as new primitives, we have a couple of new system functions. These are to do with interoperating with data stored in files, or in the case of QuadJSON, JSON came out of JavaScript, the programming language, but these days it's used extensively as a communication language, for example, between different applications on the web, or just different components of an application written in different languages that need to transfer some structured data. So it's a very simple markup language that gives you a syntax for vectors of values and dictionaries where you're mapping from keys to values, and simple numeric and character data. And this is an example of using the new system function to take a string in JSON format and turn it into the corresponding APL data, or going in the other direction, if you give QuadJSON some APL data, it will return you the JSON string encoding. And here there's a demonstration that as well as handling vectors and numbers and characters, there's also quite a nice mapping from APL namespaces to what JSON would call dictionaries. And in a similar theme, QuadCSV is used for importing and exporting comma-separated values text data, which has been used for decades as a common interchange format on disk. Again, this is an example of importing CSV. Normally you would import from a file off disk, but it also allows you to specify the content of the file literally. So I've typed in a couple of lines of CSV data there, and QuadCSV will return that as a matrix of the data. And in the other direction, if I give it the data on the left, it will generate CSV for me. And in this case, you can see it knows about quoting rules if there are commas or spaces in values. And one more kind of languagey thing that went into version 16. We've had trigger functions for a long time, which allow you to run an arbitrary piece of APL when a particular variable is updated. And we've also been talking about data binding for a few years. Originally, data binding was something that John Daintree implemented to work specifically in the .NET framework, and it was very specific to the way that .NET handles data binding. So data binding in the .NET framework is where you have a variable in your workspace and you have some kind of .NET component, and you'd like to keep them in sync. Whenever the .NET component changes, you want your variable in your workspace to update, and vice versa. When you update the variable, you want the .NET, maybe a user interface or something, to update automatically. What we've come to realize more recently is that this concept is useful everywhere, and it should not be specific to .NET. And in particular, if we're going to start promoting user interfaces written with HTML and JavaScript, wouldn't it be great if we could do the same kind of trick there and keep your JavaScript, HTML user interface in sync with the variable in your workspace? So this is the new functionality for triggers is kind of a low-level building block that allows us, or you if you want to build on that kind of idea. It gives you a way of triggering arbitrary APL code when any variable in a namespace changes, which in some ways is a small enhancement to what the old trigger does, but makes it much more usable for implementing these kind of data binding concepts. This may seem like a very small feature, but it's my favorite. Since pretty much day one at Dyalog, I got confused by save foo.dwus. You got a message that used to say, not saved, this is clearwus. And then you had to go and ask someone, what does that mean and what do I do? And they told you, oh yeah, you have to type wusid something and then try it again and it all works. Now, the message says, not saved, this is clearwus, use -force to override. Save -force, and it works. So that's a cute way of introducing the fact that we actually have these options on a few different system commands now. There's a general scheme for system commands being able to take options. That's just my favorite example. If you're into that kind of thing, Uncle Andy will be doing version 4 of his Fireside Chat sometime this week. I forget which day. And a big new feature, which again, other people will talk about much better than I can, is the cross-platform HTML renderer, which is a new GUI component as far as the interpreter is concerned, but actually for Mac and Linux is a completely new thing. On Mac and Linux, we don't have quad WC, but we do have the HTML renderer, which you can pop up on all platforms. You can pop up a standalone HTML rendering window. On Windows, it's slightly better integrated in that you can also put it inside your existing Windows GUI. On the other platforms, there is no existing quad WC style GUI. But it still works. So that's available now on Windows and Mac and will be available soon on Linux as soon as we get the gremlins sorted out. So that's a whistle-stop tour of what went into version 16. For version 17, this is, of course, a lot more speculative, but I'll try and give you an overview of the kind of areas that we're working on and the features that may appear in version 17. And of course, this is a chance for you to influence the direction. If there are things in here that you love or hate, and you tell us about it, we may listen to you. So scripting is a kind of general theme that we've been talking about for a long time, and it encompasses a couple of different things. When I talk about scripting, I'm talking partly about making it easier for you to store your APL source code in scripts, i.e. in text files on disk, for the reasons that Morten has already spoken about. It makes it much easier to integrate with version control systems and generally just to interoperate with modern build systems and packaging and distribution systems. And there are some very small tweaks that we might be able to do to make life slightly easier. For example, someone pointed out that if you write traditional APL code, quite often you find that line 0 of your APL function gets very, very long because you have to localize all your variables that you want to localize on the same line. And that doesn't play very nicely with the source code management systems because it means that anybody who updates that function to do anything that's not completely trivial is probably going to be changing line 0. And once you get into complicated source code management and you need to merge your changes with someone else's changes, the source code management systems typically give up at that point and say, well, both of you changed the same line of text. I can't sort that out for you. So the kind of thing we're talking about is giving you a syntax for declaring locals immediately after line 0. So for example, if you started lines 1 and 2 with semicolons, maybe you could specify additional locals on the following lines. And that gives you a way of grouping related locals together instead of having them all conflated on the same line. Spoke for too long. Well, I can see it, you can see it too. Good. Morten also mentioned ideas for literal notation for arrays and namespaces. Adam will be talking about that in much more detail later in the week. There are a bunch of related ideas which are to do with making it, well, like I said, two things. Making it easier to keep your source code in text files, but also making Dyalog APL a lot easier to use in the way that people use Python and Ruby as scripting languages, where you can write, you know, a short shell script or a short program and throw it at the interpreter and say, just run this. I don't want to load a workspace. I probably don't even want an interactive session or anything. I'd just like you to run this kind of as a batch job, maybe redirect some input and output somewhere. And although we've made a start on allowing Dyalog APL to work in that way, it's become clear that we've got quite a long way to go. And people like Marinus, who came to do an internship for us this summer, always point this out. They're used to the way that languages like Python and Ruby work, and Haskell, and find it a bit of a wrench to use Dyalog in the same way. So we'd like to make their life much easier. For example, you should be able to fire up the Dyalog interpreter and give it the name of a script file instead of the name of a workspace and have it just run it. At the moment, we've got some sort of ad hoc schemes, like there are diap files that let you do that, but it's not really, that was an afterthought. It's not well integrated into the way that Dyalog APL works at the moment. And once you start talking about running scripts containing APL programs, we run into various historical difficulties, like, for example, if you're typing in the APL session, you can't type a :if. You can't type a multi-line if block. And at the moment, that means that when you run a script file, you run into exactly the same kind of troubles, because the mechanism we have at the moment for running script files is pretty much just to pipe it in as if you type that stuff into the session. So I think we have a fair bit of work to do in sorting all that out, making it, I'm not saying everybody wants to be able to type multi-line control structures directly into the session, but it ought to be possible. It ought to work in the natural way, and if you put that in a script file, it certainly ought to work in the way you expect. At the moment, we're not quite there. You have to jump through various different hoops to make that work. So I can't tell you exactly how that's going to translate into features in version 17, but that's the direction we'd like to go in, and that's the kind of mode of operation that we'd like to support. For version 17 language enhancements, we generally don't like to rush into adding features to the core language. We had 4 or 5 different primitives in version 16. We're certainly in no hurry to bring out another 4 or 5 for the next release. So we're probably going to see that in version 17 we've slowed down a bit on that front. What there are going to be is system function enhancements, and in particular, Richard Smith is working on the portable file functions, which I think were introduced in version 15 and slightly enhanced in version 16. For version 17, we're planning to do a lot more work. Come to Richard's talk to see exactly what he thinks is going to be. But, for example, functions for moving files and copying files, deleting entire directories, and working on multiple files at a time more easily. Probably the language feature that I think is most likely to make it into version 17 is something called a total array ordering. This is, in some ways, a very small change to the way that grade up and grade down work, but it has very important ramifications. I think I should leave that to Hui and Scholes to explain that to you. There's a presentation on that today, tomorrow? Thursday, okay. And there are other languagey features that may or may not make it in. We've talked before about an under operator, also known as dual. We can do that. It just depends on how much demand there is for it and how well we get on with arguing about the details. Something I'm personally quite keen on seeing is a system kind of similar to when you run Dyalog on Windows, you get a pop-up status window if there are errors when you're doing some kind of namespacey GUI things. I think we should have a general mechanism for issuing warnings at runtime. This is not something you'd use in production code, but quite often we have obsolescent features of the language that are going to be removed, or things, when we introduce changes in behavior, it might be nice for you guys to be able to find out whether you're running into those cases or not. Of course, all of this would be configurable. You'd be able to select whether you want to get warnings or not. But as another example, if people are migrating from other APL systems, and we had a rash of this last year, I guess, when APL X stopped supporting their product commercially, we had a few people migrating from APLX, and we were kind of reminded of the problems that you get when there are incompatible changes in dialect. You're trying to bring APL from another dialect, and you may run into problems that are very hard to spot just by statically looking at your source code, where you really need something where the interpreter's watching what's going on at runtime. And, you know, for example, it could warn you, this line works in APLX and in Dyalog, but it means something slightly different. And the other things I've mentioned, there has been some talk of a function for formatting and parsing date formats. Again, that's up for discussion. And for a few years now, we've been talking about a new control structure called try finally, which would mirror something you get in many other structured programming languages, which allows you to make sure that some cleanup code gets called regardless of how your function terminates. So if you return from the middle of a block, it will make sure the cleanup code gets run on the way out, or even if a trappable error is thrown, it will make sure that cleanup code gets run before you leave the current function. Possibly more exciting than the language changes that we might get in version 17 are the performance changes, which you're pretty guaranteed to get. In fact, of all of these things, the thing that I'm most confident that will definitely be in version 17 is we're changing the underlying encoding of decimal floating points. I realize that most of you probably won't be using decimal floating points. It's, for those of you who don't know, it's a 128-bit high-precision decimal floating point number format, which you can use as an alternative to the normal 64-bit binary floating point. The major downside of them is that they have to be emulated in software, so they're unavoidably a lot slower than double precision floats. But for some of you, you absolutely need the extra precision that they give, or you absolutely need a decimal format as opposed to a binary format. So for those of you who are using them or need to use them, you should not notice too much from this change. We're changing the underlying encoding of how the number is stored in the bits and switching to a different software emulation library purely because it seems to give an average of about a factor of 2 performance improvement. Of course, they're still a lot slower than running it in hardware, but for those of you who are using them, that should be a worthwhile improvement. You've seen Marshall Lockbaum by now. He's been working very hard since he joined us officially in February, and has been working hard on making sure that we have really good support for all the vector instruction sets that you get in modern CPUs. So on Intel, we're talking about SSE2 and AVX2, and a whole bunch of variations thereof. On power hardware, they have something equivalent called Altivec or VSX. And even the ARM chips that you get in Raspberry Pis have a similar kind of vector unit. You'll have seen the PQA performance chart that Morten flashed up on the screen for the kind of teaser for version 17. A lot of the huge performance improvements in that are due to Marshall's work to make sure that we take really good advantage of these new instruction sets. We've been doing that for a few years on a kind of ad hoc basis, but Marshall has been much more methodical about making sure we take advantage of what's there. And another area of focus, this is not so much a version 17 feature, but something that we've been trying to focus on over the last 2, 3, 4 years, is to make it easier to work with APL and other programming languages. The Jupyter example that Morten showed was an example of this. Parts of that system are written, well, most of it is written in Python. It originally supported Python, then it supported Ruby and Java and Haskell and a million other programming languages, and now Dyalog is fitting into that as just one more language. You know, everyone expects when they get a Jupyter notebook that there'll be a support available for their language, and now they'll find that there is support for Dyalog APL. Something that Marinus worked on over the summer again was what I call an interface or a lightweight bridge to Python, which gives you a very simple way of writing APL that calls into Python code, and in quite a beautiful symmetric way, writing Python code that calls into APL. So there's a very elegant way of calling between the two different programming languages. And Marinus will be presenting that, I think, this afternoon. I need to skip on. So, apart from the kind of core interpreter work, what other kind of things are we doing? Ride is cracking on. We're committed to using Ride as the user interface on all non-Windows platforms. We've been doing our best to make sure that you get that as the default if you install on a Mac or if you install on a Raspberry Pi. And we're kind of there on standard desktop Linux as well. That's currently being developed by Gil and Callum principally at Optima, with Mike Mingard doing a lot of design work as well. I think it's got to the point where it's very usable and plenty of people are using it. We kind of realize that it still has quite a long way to go, and we're committed to working on it over the coming years and really making sure that it's rock solid as a development environment. It doesn't necessarily have to replace the standard Windows environment, but even you Windows guys will probably start to use it as you know, if you're doing cloud development or cross-platform development, it works very well as a remote IDE, which is, of course, what it was designed for running APL systems on other platforms. GPUs, I don't have much time to talk about, but Aaron is giving 2 talks this week, and one of them is about his CodeFans project. All I would say from Dyalog's point of view is that we are strongly continuing our relationship with Aaron and the CodeFans project. If you'd asked me a few years ago, I would have said that we should try to kind of incorporate GPU support into the core Dyalog interpreter. I think the biggest thing that we've learned from working with Aaron is that doing that kind of transparently in the background doesn't seem to be viable at the moment. I'm not sure anybody knows how to do that. It seems that when you write the code that you want to run on a GPU, you have to be aware of the way these things work and the performance characteristics. And Aaron and also Martin Elsman, who I think is talking tomorrow, maybe, they have a lot of really good knowledge of that kind of thing, which we are trying to take advantage of. What I think we should be doing is just making sure that it is as easy as possible for those of you who are interested in that to work with CodeFans and incorporate that into your Dyalog applications, if that's how you want to work. I'm going to skip to the CTO goals. I have to say, it's Dyalog's a small company, and taking on a new employee is a big commitment for us, and we sometimes find it hard to find the right people. I'm very pleased to say that recently with Michael Bass and Marshall, that has worked out really, really well for us. I'm also very keen on the idea of taking on interns. We've done it a little bit this summer. I'd love to do more of that. In particular, Marinus has done great work for us, and we're continuing to keep a working relationship with him, as we have done with some of the previous competition winners in previous years. And we have been talking to some other interested guys, some of whom have come from the Code Golf community, who have, they seem to have a really good kind of mix of skills. They're interested in the APL side of things, but they also know about other languages and other platforms and what we need to do to interoperate nicely with them. The GPUs and bridges I mentioned, performance is, I hope, continuing to improve at a more dramatic pace now that Marshall is with us in particular. And the cloud deployment that Morten rightly spent a while talking about. I think we have a good basic story with the cloud deployment. We're very good on cross-platform support, and we have ways of launching and controlling processes on remote machines and working with them. As Morten said again, the isolate system works well in that kind of way. I think the only thing we're lacking there is real experience of big cloud deployments. And I know some of you guys are either thinking about that or have already started doing that. So all I would say is we would love to talk to you about that. We need to kind of share experience and work out what more we need to be doing as a company and as a product to really support that mode of use, because it seems like it is really going to take off over the next few years. I'm out of time. I guess I should ask for questions, maybe for, anyone, Gita, Morten, or me at this stage, and then we'll go for coffee. If you do have questions, please come to the microphone. Can we have...
Workshop. There's a workshop on Thursday on cloud development, deployment. So there's still time to sign up for that.
Okay, if there are no questions, we're going to break for coffee. And start back here at 11. Okay.
Okay, welcome back. I'm really happy to introduce Aaron Zhu to you. Many of you have seen him before talking about his compiler. And Aaron's one of those people who, although he understands us and we think of him as a member of the APL community, he actually spends most of his time outside it, talking to other kinds of programmers. And I was really fortunate in June to have invited myself to be his workshop assistant at LambdaConf in Boulder, Colorado, where he was faced with a room full of, I think, mostly Haskell programmers and needed to motivate them to learn APL. And Aaron's been thinking a bit about this problem where it's actually quite easy to blow the minds away of non-APLers, show them a few outer products and stuff, and they say, that's really cool. But then when they try to learn it, they find that a lot of the things we do in APL are really counter to many of the things that they have learned. And he did this introduction where he tried to motivate and contrast aspects of APL. And I think that's what he's going to show us here today. Aaron.
Thank you. And yeah, so this has come about because I've been really interested in education for a long time, and I've been wondering how you teach APL, both to experienced APLers, how do you explain what you're doing, talk about it, things like that, and also when you've got these newbies, how do you onboard a new programmer, especially somebody who has some prior computer science experience. So, as is usual for me, I need to disclaim what's going on here. So I can't help myself. Gita phrased it well. It's going to be a sermon, lots of preaching. Probably no fire and brimstone, but moralistic rambling is definitely going to be in there, and probably a little hyperbole. So take this all with, the appropriate amount of salt, something like that. Yeah. So don't be fanatical. Enjoy yourself. Have fun. That's one of the reasons I love APL. So the first starting point we have to look at is that APL does have a little bit of an infamous reputation, and we have these two worlds where we have people who really end up loving APL. They tend not to be classic computer scientists, and then we have the programmers who tend to be more orthodox or more in the academic computer science world or the new wave of computer science. That stuff, they really look at APL and something immediately turns them off. And you get this situation where I've seen this a lot. This is, it's a meme, but it's not a meme. I've seen this face on all sorts of developers when I present some code to them, and they all tend to have a similar pattern of being computer scientists, and they struggle with these ideas that we present that I personally I'm kind of in love with. And not all the computer scientists are like this, right? We have people like Alan Perlis who talked a little bit about the language, and we get some themes coming out when people talk positively about the language, things about tersity, flexibility, composability of the language, but these ideas of an artistic element or this natural language concept or the naturalness of the language is a common theme that begins to come out, and that's what we're going to begin to explore a little bit more in depth. Now, this presentation is going to be available online, so there's a little more verbiage than I usually put into a presentation. That's to allow you to go back and read through the presentation later if you want to and play with it. So you don't have to worry about reading all the words. I've sort of bolded the big important points, but you can go read the verbiage in more detail later if you'd like to. So we have this problem where we get this impression, especially with people with prior programming experience, that APL is really kind of hard to learn. They sort of can see the easy parts, they understand what the language does, they understand the syntax, but they couldn't write a beautiful one-liner to save their life, right? It's really, really hard. They could write Python code using structured APL, but they can't write the APL code that we think of as very useful in exploring problems and solving things, this notational thinking that everybody talks about in APL. So to explore this concept, I go back to the beginning. What is the process that a beginner goes through when they want to learn APL? Well, today, in our current framework, usually they get to see John Scholes' work here with the Game of Life, and that's a 5-minute wow demo. It blows people away. And you get one of two responses, right? You say, wow, really cool, but how on earth could you ever do that? How did he ever come up with that idea? Or you get what people in the programming languages community say, and they go, wait, there are no ADTs, there are no types, there's no pattern matching, where's your recursion? No way, I ain't touching this. No way whatsoever. So there is this learning wall, and there's a learning wall in every programming language, but APL is somewhat unique in that that learning wall comes up really fast, really early, and smacks you upside the head. And then once you get over it, there's like this nirvana at the other side, but that wall seems really insurmountable when you begin. And so the question is, how do we overcome that? How do we deal with that? And we can start by remembering a little bit of our history. So if we look back at the history of APL with Iverson, we have a whole set of sort of early writings or early works that describe the mindset of how we're going to interact with APL. And I think sometimes it's easy to forget the core of the design principles behind how it was created. And in Iverson's Turing Award lecture, he leads up his lecture with these two really interesting quotes, and I really like these, so I'm going to read them out. In Whitehead, we've got, by relieving the brain of all unnecessary work, a good notation sets it free to concentrate on more advanced problems and, in effect, increases the mental power of the race. And then Babbage has a similar concept where he says, the quantity of meaning compressed into a small space by algebraic signs is another circumstance that facilitates the reasonings we are accustomed to carry on by their aid. And these two really set the stage for a difference in philosophical opinion or a philosophical approach between APL and the other languages. And a lot of people like to think, oh, you know, all the languages are more or less the same because they're all Turing complete. But the philosophical underpinnings behind a language can vastly alter how you look at the world and how you train and how you tend to approach problems. And so this is really important. So let's do a quick show of hands. How many people have heard of Iverson's 5 design principles for a language? All right, quick test. Who can tell me them by memory without looking them up? Anybody? Okay, do we have it?
Executable. Analytical. Can you shout them out after what you said?
Yeah, so we've got executable. Provability, or amenability to proofs, yeah.
Applicable in many areas.
Yep. Ease of expressing contrasts, generality, yeah. Close, yeah, so that's 3. But you've got suggestivity and economy and the ability to subordinate details. So executability, I've sort of, you know, is mixed in with things like ease of expressing construct. But these 5 principles, everybody's heard of them, everybody sort of recalls them fondly, but nobody actually thinks about them when they're doing their day-to-day programming. And part of the reason is these are pretty abstract. So let's start by going through them in a little bit and cover them quickly to get a feel for what Iverson was talking about. So the first one is the ease of expressing constructs. And this is about directly expressing solutions, not about the ease of expressing abstractions, but the ease of expressing different ideas and ways of thinking about problems. And so it has an implied generality, but also an implied directness to it, which I think is important. And then we have suggestivity. And suggestivity is a really interesting one because you don't see it a lot in other languages or other design philosophies. And this one is the idea that seeing a piece of code can suggest to us new ways of thinking about a problem, or new possible ideas, new theorems, new coding examples. So in his lecture, he gives one of these classic examples of these equivalents between addition and multiplication and exponentiation. And this is a concept that is sort of subtly used, but people sometimes don't recognize when they're leveraging this feature in APL. And the ability to subordinate detail, if you show this to a modern computer scientist, they go, oh yeah, I absolutely agree with that, totally. Abstraction, ADTs, hiding details, OOP, all that stuff. And that is not what Iverson actually meant in the context of when he was writing this piece. Because the ability to subordinate details isn't the ability to hide details so we can't see them. It's the ability to put them in a place in an order of priority such that even if we do see them, they don't cause us a notational burden. And that's the important thing, is we have to eliminate notational obligations rather than hiding those notational obligations behind libraries in order to get good ability to subordinate detail. So when we talk about economy, he's got quite a lot to say about economy, and we can read this at some point. But a lot of this has to do with composability. A lot of it has to do with the idea of how well things fit together efficiently. And I want to extend that with this idea of scalability. And so there's this tension in economy of what you can say about the world and how much words or how many words you have to use to say it. And how many different words you need, how much vocabulary do you need. So when we talk about the economy of a language, we need to think about directly expressing what we want to say and not what is the smallest amount of things we can use to say or solve the problem. So when we think about the economy of a given language, we need to think about what we actually write in that language when we want to solve a problem. So there are lots of Turing tar pits that have very, very small primitives, but to do anything in those languages, we have to build up a huge framework and infrastructure to get anything done. So when we think about the economy, we have to include all of that additional framework, all of that additional tooling that we use to work with a problem, not just the core primitives. And the amenability to formal proofs is interesting because I call this the blackboard metric. Because this isn't about mechanized proofs. Today we use a lot of tooling to support mechanized proofs, but that's not what this is about. This is about your ability to do symbol pushing, to manipulate your code on the blackboard and do reasoning about it between humans, not do mechanical proofs on something and let the machine take care of thinking for you. Now, that's not saying that the tool support isn't pretty cool, but that's not what the idea behind a good language notation is. The language notation shouldn't rely on mechanical proofs for you to be able to think about a problem. So, those are all really abstract. And if I asked any of you how you use those in a daily basis, you might be able to fiddle through and talk a little bit about how you use it. But the bottom line is, if you were trying to teach a new person, how many of you think you would be able to take that and then give good advice to a newbie on how they should think about solving their problems or how they should think about working with the problems? These are very abstract. There's something that an expert uses to describe something, but they're at a very high level. So when I was thinking about how to work with computer scientists, those abstract ideas are a little too abstract. We need to bring it down. Bring something more concrete that they can work with. And one of the problems is, in other languages, we have style guides. And style guides serve a purpose of creating this common structure visually of how we interact with our language. And those are combined with software engineering best practices, which allow us to sort of have this constraint on the design of how we solve a problem, and then that allows us to explore more efficiently. We don't have that in APL. APL is a very artistic sort of language. So what do we have instead? We have a whole bunch of styles. One person, like Scholes, is going to write with some defuns. Maybe it'll look a little lispy, lots of nested vectors. Another person who's going to spend all their life in J is going to do, maybe use a lot of the higher operators, going to use flat rather than nested more likely. Somebody who's been using APL for a long time, they're all trad funds. They might be using go-tos because they think structured things are silly. Another person's going to use structured. And they all look entirely different to the outsider. And so you look at this APL code and you go, what's going on? And so we can't quite reach the point where we say, there's this nice little style guide that's going to solve all our problems. We'll have an idea of what's going on. So we have to pick a middle ground. We've got this highly abstract set of principles, and we have this set of styles that we use. In between there, my claim is we have a set of patterns, a set of practices that are more concrete than these design principles that we tend to use. And more importantly, they tend to be features of what we hold up as interesting code or good code or code that we sort of admire or that gives us pleasant, warm, fuzzy feelings when we work with this stuff. And so I developed basically 8 patterns that I consider important when we think about how to design good code. Now, how does this apply to the beginner that's just learning the code? Well, it just so happens in an unfortunate state of computer science that these patterns are more or less diametrically opposed to everything you're told to do in computer science when you learn. So you basically, get this dichotomy. And this dichotomy, on the one hand, has all this beautiful APL code, but implicitly in this design philosophy that's being expressed in this great, nice, cool, neat APL code, you get a set of practices that your mind is saying, no, this is evil, this is wrong, this is bad, no, this is no good. And so we get this conflict, this direct pattern, anti-pattern tension that occurs between traditional programming practice and the APL programming practice. And so if we can sort of consciously recognize this, we can become aware of this issue, and we can think about that, and we see that in our tendencies when we introspect on our process of how we go through code, and when we look at students or new employees that are coming in, and we watch them and we see the patterns that they're making. If you watch carefully, you can see them making these decisions. So you can see them choosing to go towards the traditional approach rather than what I would call a more idiomatic APL approach. And if they do that, they're going to have trouble down the line because solving the problems will be difficult. So a classic example of this at the LambdaConf case that we had, there was a Haskeller. He had to write some random numbers. Now, in APL, we know how to do random numbers. It's, hook reshape. Boom, done, good, yay. He started with a good lambda abstraction, mapping over the iotas of the each and the ranges, and then decided, now I've got to figure out what goes inside of this lambda, because clearly this is a mapping, since we have to do each over it, and now I know I need to use hook somewhere in there, but hook with what and where so suddenly he's got this thing that's already 5, 7, 10 characters long, and he hasn't even got it to produce a result yet. And when I went and just typed up the maybe 5-character solution or 3-character solution to give you the random numbers, he looked at it for a second, went, and looked and went for it. And the thing was he never would have thought that was a viable way to look at the problem. And these are the sort of things that you watch for if you look at what they're doing, because they're going to make those kind of assumptions. Now, interestingly enough, if you have no experience with computer science, your first intuition when it comes to generating a set of random numbers is not to build a lambda abstraction with each. But if you have computer science experience, that's clearly the first right answer. So what's happened, my claim is that over a period of time, computer scientists in their lifetime, maybe starting young, at some point when they went to university, they've been trained to be good computer scientists. And maybe the state of computer science education could be better, but they're pretty good at convincing people that there is a set of best practices. Pick good variable names. Use the right abstractions. Keep good barriers around your code. Don't let leaks go out. Defensive programming. Make sure you don't have errors blowing up everything all over the place. Traceability, good debugging messages. All of this stuff is things that they're told they need to do. And so then it almost becomes a moralistic element. There's internalized to a degree it's the highly refined critical aesthetic of an arrogant artist, right? They look at the thing and they immediately can identify this is good or bad. And they might not actually be able to tell you exactly why it's good or bad, but they know it's good or bad, right? And so what they've done is it's become so internalized in them that often they can't even, they don't even realize that they're making decisions about how to write code based on these ways of looking at problems. And APLers are not immune to this either, right? When I worked in APL, I had to think, well, okay, I could write it this way, but it doesn't feel right. Either it didn't feel right in APL or it didn't feel right to my computer science-y mind. And so exploring that and working down those things is what helped me to find what I consider better solutions to the code. And so if you try to just treat APL like another programming language, and you just proceed to use all the stuff you learned in school with APL, you're going to go crazy. It defeats the efficiency of the language and your sanity. So, the solution, in short, easy, is free your mind. Let yourself ponder and play with APL without letting yourself be connected to the dogmatic notions that you had beforehand. And that doesn't mean that those dogmatic notions are not true. They are technically true. It's just that APL presents a different design space that you have to account for. You have to adapt for it. And so if you can recognize and adapt for that, I claim you'll have a lot easier time thinking about your programs. Or at least you'll be able to recognize when you've hit one of these walls and try to work through it. So, there are 8 of these patterns. And what we can do is you can apply this to existing APL code, or you can apply it to your new code that you're designing, or your learning process when you're thinking about how I'm going to work with code. So it serves as a metric for code review, serves as a method to help onboard new programmers, etc. But you have to recognize that they tend to contrast the traditional patterns. And not all APL code looks like this, right? But the APL code that doesn't look like this is not the code that somebody shows on their blog post because they're so proud of it. That's the kind of code that's hidden behind NDAs. So, the first pattern, and this should surprise nobody here in the audience, but I don't think that people understand brevity versus verbosity. People say, oh yeah, APL is short, but what does that actually mean? And it's not terseness for code gall's sake, right? Brevity serves real useful purposes inside of the APL language, and even though everybody else says they like shorter code, when actually put to the task, most of them will prefer a more verbose solution up to a given metric, as opposed to the truly shortest possible solution. And a classic example of this is average. And average is actually a really good example to study some of these patterns across the board, because it's very short, it's very simple, and it doesn't use too much complex stuff to think about. It's a short one we can work with. So when we're going through these patterns, think about average as well as some of the other code I show, and see if you can see the patterns and how they're approached. But brevity relates to readability, and terseness is usually considered a bad thing because readability is considered such an important thing, except that nobody actually can define readability. What most people mean by readability is how comfortable they are when they see a piece of code for the first time. And I would argue comfort is a really bad metric for determining whether code is readable or not. And so brevity serves actual readability benefits in terms of being able to memorize the code, being able to remember the code over time, being able to pattern recognize on the code, all of these pieces. And so brief code is more malleable code, and it's easier to see as a whole. And that seeing as a whole theme is going to connect throughout this whole conversation. But also, APL is one of those few languages where many, many people are able to whip out memorized versions of code that do things that people would normally have to go look up in their Java docs or their API references to figure out how they do it. They would use Google or Stack Overflow to pull up that code, and they'd copy and paste it. Whereas in APL, a lot of people, you ask them about some piece of code, and they're just going to whip it out. Write it down on a pen. Oh, I love this piece of code. It's this. They have it memorized. You don't see people memorizing their favorite piece of code in other languages. Not very much. Occasionally, you get somebody, but he's not going to write it down for you because it's going to take too much time and he doesn't have that much ink in his pen. But when you get to that point where the code is so easy to write, that has mental effects on your ability. And when the code is short enough, that changes the way you process the code. The chunking, the memorization, all of that goes in. And it's more composable. It's easier to integrate a small piece of code that's general into your framework than it is a highly architected giant piece of code. That's why we have these whole integration experts in middleware inside of the rest of the industry, because that is a full-time job, thinking about how the architecture is going to fit together, and they let somebody else do the actual programming. Whereas at scale, you might have to deal with that at APL, but the scale is shifted by quite a bit of difference. So that leads us to this concept of macro versus micro, right? And if you look at a traditional programming language, the emphasis is this. The idea is, in a regular programming language, hide all that big picture nonsense and make sure you can highlight what's actually happening at the detail level. You really lift out the details. One of the classic examples is the NanoPass compiler. And the NanoPass compiler hides away all the tree traversals for managing tree flow. or managing tree traversals and tree transformations, and instead gives you a pattern matcher that allows you to really, really illustrate what happens on each specific node. And it's a great framework in that language. It's my favorite compiler framework for working in Scheme, but it's a micro-focused system. It hides, the overall big picture is entirely implicit, and what you see is the individual node-level operations that we're performing. APLers don't tend to think of that code as very nice. APLers, on the other hand, prefer their code more like this, where you see the big picture as much as possible, and then the little details don't bother you as much. And so there's this underlying theme in good APL code of seeing the whole picture, seeing the big picture, and thinking at a macro level. And there are tools that help with this. I asked Roger for his favorite version of this, and he gave this to me, and I actually think it's a really good example, where you're demonstrating uses of hash functions, where you've got this hash function here, and you're creating a partition using that hash function. And there are all sorts of things that we could imagine this looking like in another language. But if you look at this in APL, every APLer is going to see the structure of this and say, oh, that's a pretty simple structure, and they can see the big picture. What's the big picture? It's the giant key sitting over there. That shows us what the big idea is, and then we can sort of reason about the whole rest of the thing after the fact. So this kind of code won't look like this in another language, but in APL, we like to be able to see what is our big picture without losing the details. That's an important thing, seeing the whole picture. So transparency over abstraction. This is one of my favorites. So if you haven't guessed already, I like to have fun with my programming. And when I talk about programming to other functional programmers, we talk about abstraction a lot. That's a huge aspect, and so much so that Knuth even thinks of the ability to work with multiple levels of abstraction as one of the defining psychological characteristics of a programmer. So, we can go back to structure and interpretations of computer programs and look at how they thought about it. And my favorite tagline, abstraction considered harmful. I love this, and what's great about it is I can actually say it with a straight face. And you can't do that in any other programming language. You can't say something like this and be in any way sane in any other language. The abstraction exists for a reason. There's a reason we've created it and a reason we've built so much around it. But in APL, we've shifted the game. The cost-benefit analysis is different. And so for the most part, what you want to emphasize is less idiosyncratic specialized functions for specialized data types that are going across. And this was a classic example of what made Lisp so useful back in the 80s, 70s, this area, right, is this textbook that MIT used to use as their textbook in the early days said it's better to have 100 functions working over one data type than 10 functions working over 10 data types. And this idiosyncratic tendency that we have has permeated most of programming. What do you do in most functional programming when you want to solve a problem? What is my data? What is my data type? Build an abstract data type encapsulating that data. Now we build functions to work with that data, establish the error conditions and the boundaries, and now we write our actual piece of code. In APL, that's actually an anti-pattern. You do that and you're reducing the usefulness of your code. And we'll talk about that, but basically, a good APL program makes the idea clear without needing to build abstractions to hide the details, and it avoids being idiosyncratic. It avoids being too specialized, because the more general the code is, the more likely that you'll have a suggestive generality, more likely that the code will suddenly, almost serendipitously, be applicable to something else. And if you have a data type for prime numbers that you've created, might have all sorts of nice type properties, but now anything you write around that prime number thing will not be automatically applicable anywhere else. You have to do more work to make it apply somewhere else. And the chances that you'll recognize that it's applicable somewhere else is difficult because you've hidden the implementation. So you can't see that the execution behavior is the same across the elements. So instead, really nicely written APL code has two levels of abstraction. The foundation level, which is APL, and then whatever the problem you're solving is. The user's problem space. That domain is where you want to do all of your new abstractions. You want to make those abstractions so that the user who's reading that code, who's designing the requirements or whatever you're working with, can see that and only sees that kind of stuff. It's an idea of semantic density that Stephen Taylor's in his direct development has talked about. And so the native problem domain and the core linguistic primitives are your two abstraction layers. And every time you insert an abstraction somewhere in the middle there, you're making it more difficult on yourself. Now, maybe it's necessary. Maybe you have to do that. Maybe it's an important requirement. But the more you do that, the more painful it gets. So the less you have to do that, the better. Now, idioms over libraries, this is a bit of a contentious one because everybody loves libraries. But when APLers think of libraries, they don't think of libraries the same way that other people think of libraries. And again, I go to Knuth. Now, of course, Knuth is a bit of a black sheep in this regard. But I think the APLers can agree. When you have code that is idiomatic and re-editable, it's infinitely more useful to an APLer. Now, that doesn't mean that you don't have it ready out of the box to use as a library function. But if you told the APLer that they're not allowed to look at the code of this library function and that they're never allowed to tweak it, well, that's a much less useful library. For an APLer, a good library is one that you can re-edit and tweak and specialize and read the code for. And Knuth likes this as well. He doesn't like black boxes. So the idea is that when we have a problem, the ability to adapt based on the structure of the code of these idioms and adapt these idioms helps readability. It helps scalability because we can now recognize code that are in the same family and see new ways to adapt that code without having to have a giant API reference. And it reduces our documentation burden as well, because if you have a bunch of black box library abstractions, suddenly you're going to need documentation telling you exactly what the edge cases are. Go back to our average function. That average function tells you exactly how that average is computed. So now you don't have to go to the documentation to ask the question, well, what happens if we have exceptionally large numbers and could reach overflow with the addition before we do the divide, and it won't fit into the space of whatever our number representation is going to be. Whereas if you're computing averages in other languages that have an abstraction for your average computing, now you have to ask that question, does our average function handle that computation or does it not? And now you have to have documentation saying whether it handles that edge case or not, whether it's appropriate for that. And if it doesn't, well, then you're probably going to have to write something else. With the average function in 4 characters, we answer all those questions without the need of documentation or any of that extra stuff. So the editable code is useful, but it's also useful because it helps us to simplify the namespace. If we're working with idiomatic code, we don't have to rely on names as much. Instead, when we compose the idioms, we can leverage the structure to see the patterns and to make the code readable. And if the structure is more readable, now we have to use less names, and that means the names can be used for more important things that more readily communicate what we're doing in the program. So we don't need as many silly names that don't really contribute to the understanding of the big picture. So now, we have idioms in other languages, sure. But generally, they're called design patterns, and generally they happen at the macro level, where we're trying to hide a macro process or trying to plug in and thread a macro process around in some reliable way. We're relying on a mechanistic behavior. It's a way of getting guarantees mechanically or semantically rather than helping us to visually understand the problem. And they're less useful as editable code objects because APL idioms generally are small, and so we can compose them together much more easily. If you've ever seen a Java project trying to compose multiple factory idioms with multiple visitor patterns and then this other stuff, just don't. So instead, we could have something like this, where everybody is going to recognize that top idiom, right? And dot equals, string comparison. In Java, that would be match list of strings or something like this, map all of this stuff. But this is the same basic idiom, right? This is also an and dot equals. We just tweaked it a little bit. And all it is actually, before I say it, does anyone take a guess at what this might do? Not to throw you on the spot or anything like that. I don't expect you to be able to fully intuit it, but because it has a lot of different uses. But I've got a specific use case for which this was very valuable. And this was prefix equality. So if you've got a matrix that you're comparing against and the trailing elements are 0, and you want to compute the prefix to see whether a given thing is a prefix of the other, you can use something like this. And it's essentially the exact same computation that we're doing with and.equals. The same way we think about the problems of and.equals we can apply to this prefix equality. And you couldn't do that in a library where you've got 2 separate API functions for managing both of them. Or worse yet, a template C++ metaprogramming system where you've got to plug in the different ideas into this system, and the next thing you know, you're getting a 10-page error report because your types didn't match and you have no idea what's going on. So then we have data over control flow, and this is another one that I think most APLers should be pretty familiar with. Logic encoded into our data, Boolean variables, all that stuff that we're able to work with. Now, of course, the functional programmer can't help themselves. But when you tell them, no, we don't need control flow or pattern matches or anything like that, we don't need if statements, well, things go haywire pretty quickly there. So instead, what we can use is trains, array-at-a-time programming, native support for Boolean arrays, and the first-class nature of shapes, indices, and other things to reason about arrays and compute over them. So now this is a scary piece of code. But believe it or not, it's not so scary. So this is a train, because I like trains. But I'll point out some of the big points. Big picture, we've got a filter. Here, we've got a scan partition. We're basically creating a partition. This is working over ASTs. This is a line of code in my compiler. So what we're doing is we're creating a partition of all the nodes that belong to various first top-level function definitions here. And then what we're doing is we're asking, well, let's look at only the operator and function nodes, and they have to not be binding nodes. So they have to be nodes that aren't binding types, and they have to be at the top level. Okay, and so now let's filter out these elements from there, and that'll give us the set of indices, or partition identities, or hashes, or whatever you want to call them, for all of the top-level functions that are unbound. And we don't need unbound top-level function definitions when we're compiling because they're never going to be used, so we can get rid of them. So we can just use this membership to get a mask of all of the nodes that belong to those top-level elements and delete them. And now notice, we didn't have to use any if statements. We didn't have to use any pattern matching. We didn't have to use anything like that. We just use a basic logical expression, and everything, the big macro picture is very clear. If you did this in NanoPass, it might not be clear that what you're actually doing is a filter or a delete. But here it's very obvious that that is exactly what you're doing, is a deletion. All right, structure over names. So in APL, I've talked about this, but if you can design your system so that you're leveraging your structure, making it simple, making your control flow simple, making everything data flow, or oriented in such a way that you don't have to rely on names as much, what happens? Well, we don't need as many names. And that means the names don't have to be necessarily as long, which has a positive effect. Eventually, if you're working on the other best practice and you're making names, good names, long names, eventually the name becomes longer than the implementation of the code. And at that point, you've got a problem. Because eventually, as you need more names to describe what's happening in the system, you lead to this little system problem. Now, fortunately, APL, that space can come up really fast. So here is a recommended Java type. It's a declaration for a function for working over prime numbers. And of course, you need the documentation because every good Java programmer knows Java APIs are the way to go, and you need Java docs, and you need to document all your edge cases, your inputs, and everything like that. Great. What if we just did some APL? Now, if you guys have counted numbers, this implementation is actually shorter than the name that they recommended for this function in the Java. So I'm not lying, it's actually happening. And what's more is I don't need additional documentation for this because all of the possible behavior characteristics I wonder about are all in the name. I know that it's a quadratic algorithm. I know it's going to involve binaries. I know its limitations. I know its range. I know how it's working. I know all of that from this without the need for names. And it's kind of an idiomatic thing. So by doing this, we free up our namespace to pick names that are more valuable to us and describe the more important concepts, rather than having to worry about names for prime numbers or something like that. So we have our little cycle of improvement, where we reduce our name dependence, which means we get better names, which means the names get easier to use, which means it's better to have good structure, which means we get less name dependence, which means we get better names, and it all keeps working. So what's in a name? Potentially everything. And of course, the interplay between names and structure is not binary. Disclaimer, results may vary. You're responsible for the code you write, et cetera, et cetera, et cetera. Implicit over explicit. So the issue here is we really want to leverage that suggestive generality that I was talking about. So we want to go beyond the originally intended domain if possible. And we can do this by eliminating the need to worry about piddly little details and let that be implicit in the code. And by doing so, oftentimes we can find that the code applies and is more useful than we originally thought. So I'm going to have to start accelerating my talk here, or we're not going to have as much fun. So this is an example of what not to do. This is a different language. You guys may recognize it. The problem is that if we go too much in one direction, we're going to get Turing tar pits. If we go too much in the other direction, we're going to end up with DSL explosions where we can very quickly express exactly what we want to express and nothing else. And so we have to have a new language to solve the next problem. So instead, we pick somewhere like this general purpose domain-specific language called APL. And here's one of my favorites, syntax over semantics, because good APL is focused on the human experience, not what is happening on the computer necessarily. Yes, the computer is important, but what you really want to think about is how are you communicating to the other person that's reading this code? What is the idea? What is the interaction? What is the process and the behavior and the whole human method that's going through when you're working with good APL code? And you want to optimize for that experience. So conventional wisdom says that the syntax doesn't matter. All that matters is what the semantics are doing and all the robust guarantees. So when a computer scientist looks at a language, they say, what are its semantic guarantees? I don't care what it looks like. But this is a mistake because our language actually alters the way we think about the problems. So syntax matters. Syntax allows us to think about problems differently and allows us to interact with that problem space differently. And that's that interaction that's important, the HCID of programming languages. And I had a colleague that basically felt like this whole approach was so foreign that there's this secret Illuminati that's been going on since the 60s that's been sort of paralleling development in computer science, and they're now just like coming out of the woodwork and surprising all the rest of the people. So when you're designing code, I encourage you to think about what are you doing to your friends when you write this code? What are you doing to the people, your colleagues? Not so much what you're doing to the computer, but what is the human experience that people are going to go through when they work with this code? And are you actually reducing their mental burden in the long run? Now, short-term thinking doesn't help here. You got to think long-term. Are you fundamentally improving the state of things? So here is some other code. I can only go through this quickly, but the idea here is this is code designed with syntax in mind, not with semantics. So this is a parser combinator library. And if you guys are familiar with parser generators or anything to do parsers, you know they don't look like this. This might be the first step in the documentation of the man page describing it, but under the hood, they look nothing like this. They're insanely complex, and they try to provide all these robust guarantees and optimizations and things like that. This, instead, is a set of operators designed to allow you to write BNF grammars in APL, so that when you read your parser, it reads like a BNF grammar. and you're able to work with it like that. And there are all sorts of little semantic open spaces, implicit elements there, where you can blow things up, break it. The semantic boundaries are really loosey-goosey. It gives any computer scientist a pretty big heart attack. But this allows me to put my parser for my compiler on 2 pages, including the implementation of the parser generator. So I never have to look at documentation to figure out what the parser is doing. I know exactly what it's doing because I'm looking at the code right next to it. And I can read my parser just like a BNF grammar. So it allows me to think about it just like you would any other language description. But I see the whole picture because I'm focusing on the syntax rather than the semantics. So we've got a little bit more time. But let's focus on when we go down and we apply these to specific styles. You need to think about how you're going to frame your problem based on your options of styles that you can work with. So nobody really does box diagram APL anymore. It's kind of sad, it's fun, it's nice, it's traditional. This is what traditional APL looks like. Quick question, what is this? Come on, know your code. It's like... Yes. Yes, this was the APL compiler system from direct form to canonical representation that was given in the Turing Award lecture and in other places, right? I'm glad somebody knows there. Basically, traditional code should no longer be considered canonical, in my opinion. This is a good method if you have to support legacy code and if you have to use dynamic scope for some things. But basically, the problem is not the use of gotos. The problem is dynamic scope. Dynamic scope really messes with the brain. So don't use it unless the user problem space maps directly to this kind of expression. Otherwise, find something else. Yeah. The only place where I will allow an exception, in my opinion, is when we need to insert definitions into other scopes. So a poor man's macro system. So for example, in test suites where we're generating new code to generate tests, we can use the execute function and dynamic scope with the traditional style to help make a test suite generator. And I have this in the compiler where that's my main use of dynamic scope functions. Structured APL. Does anybody know what this one is? This is, yes? Yeah. So this is from a paper about direct development and pair programming with the users, coming out of, I believe, Optima? Yeah. So this code, the reason it's useful, it's got all the same problems of traditional stuff. The only reason it is useful is if you are specifically working with a problem domain in which it directly maps to this structured problem domain. You shouldn't be using if statements if the if statements don't directly map to the problem domain you're working with. And one of the big problems is that both traditional and structural styles suffer from a heavy sequential bias and over pollution of the namespace. And both of these have consequences in terms of how you're moving forward, because it makes it harder to parallelize, makes it harder to analyze, makes it harder to work with, all of these things. So then we have didactic defunds, and I chose the word didactic very intentionally. Here's the dictionary definition. Pay attention to the moral instruction as an ulterior motive. So with didactic defunds, this is the way the defunds library works. And you've basically got your code on one column and your comments in another, Cliff Notes version, running style, all this stuff. It's very bad if you have to edit your code a lot. If you're editing your code all the time, this scales poorly. It also scales poorly as your dependencies increase. However, if you've got a standalone function with few dependencies that is mostly going to be read by first-time uninitiated people, this can be very good for doing a hand-holding situation, seeing the picture, and leaving relatively static code alone and working. So this can be very useful for little library functions, helper functions, utilities, that kind of thing. But the rule here is read often, edited little. And in here, instead of using structure control, you use functional programming techniques, recursion, the defunds box technique, things like that. Bag of defunds is the Scholes live demo style. It's really good for exploratory programming, illustration, things like that. It's one of the most scalable styles. It works really well inside of the session. It's very similar to traditional styles. What the benefit of this style is that you can easily go from here to didactic defunds, and you can go from here to train style functions. pretty easily. So it's a fairly good general purpose style. But we have tacit trains functions. Disclosure, my favorite style. I'm highly biased here. The benefit is that you can say a lot with very little. It's the ultimate in terms of implicit behaviors. You eliminate the need to do data variables pretty much entirely. This is an example piece of code taken from my compiler. It does function lifting, or lambda lifting. And if you look in the literature, you'll find this is a pretty short definition of lambda lifting, especially since it's complete. It's not an academic pseudocode that doesn't really do it for a full, this does it for a real AST over real code. So it's points-free, minimal scope, it gets rid of the issues with lexical versus dynamic scope, pure functional, pure data flow, easy to parallelize, all sorts of stuff, really good for being terse and the like. Biggest disadvantage, it's absolutely alien to many people. So there's that bump. You have to be willing to accept a different way of interpreting expressions. But if you can accept that, it gets the closest to lyrical programming, it gets maximal malleability, and it tends to be much more regular in behavior and regular in appearance, and you can see more of your code, which I consider really important. It's very difficult to map to some business logics, so you have to be careful there. And you have to choose based on your domain, your user domain, because some business logics are not going to map well to data flow without additional work. But you can leverage idiomatic expressions really well and toy with your semantic density levels really well with it. And of course, you can mix and match. So here I have a parser that's written in the bag of defunds style using those parser combinators you saw before. And then I have a defunds in the compiler as well for two different areas that apply better in the two different regions. So I can mix and match the styles without causing a great deal of cognitive dissonance. So we are running out of time. So much to talk about. Fortunately, that's the big picture. 8 patterns. That's the big idea for the most part. And this section is sort of on the myth of readability. And this comes up because when I talk about this stuff, everybody, everywhere, always says, well, how do you read the code? You know, it's not readable. And so we end up having these 5, 20-page Hacker News discussions about what readability is. So before we go into this, I'm happy to go into this, but this is available online so you can read it as well. So I figured I'll ask if you guys have any questions to start with, or we can go have some fun with the myth of readability. All right, moving on. So basically, APL is the classic poster child for a write-only language. In reality, that's just flat out wrong, but you have to actually write APL to understand that. So you've got the comfort zones, right? I like this one. Red is APL, right? Growth zone is maybe Agda, Haskell, template, C++ metaprogramming, something like that. Python is nice in the blue, right? Or the cyan, something like that. But the reason we have these comfort zones is because comfort is the readability. To everybody, readability is usually, can I look at it and feel good? Feel like I got the idea. It doesn't matter if I actually know what's going on. It doesn't matter if I can actually change the code at all. It just matters, do I feel like I kind of get the gist of what's going on? That's readable code then. You have to think about comprehension. So the way we think about readability right now is the wrong metric. Let's use a new metric, a new definition of readability. You guys should like profit and loss, right? So I like to phrase it as it's the amount of money that you're willing to bet that a change you make in the code will work the first time without breaking anything and without mechanically testing it first. This removes the ability to use a mechanical proof theorem system. A mechanical type system is not allowed. None of that. It is just you and your code, a cup of coffee, and lots of money. So this gets around the comfort issue. Because if you're on the line, if your bank account is on the line, you're not going to care about comfort, you're going to care about confidence. And that's a better way of thinking about readability. You need the confidence to measure how ready you are to make broad sweeping changes to the code. Now, for the traditional programmer, if you restrict them to making local changes, no problem. Local changes are usually very well optimized in traditional languages. So you've got isolating of specific code for local reasonability, that's usually pretty good, right? APLers do the same thing, but they tend to focus, local means the single line in APL, or it should, rather than the single 100 lines or so, or 1,000 lines of code that you read elsewhere. But that's only part of the picture. We've got another part that's missing, and people don't seem to talk about it. They seem to think that their code should be readable, but when we talk about architecture, now it's okay for the code to be entirely unintelligible, and we'll just rely on a UML diagram to explain what's going on. Because that's better. And so when APLers talk about readability, an implicit element of readability in a good APL is the architecture, the big picture, the way everything plugs together and fits and works together, and all of it combines in a nice way. And other languages are hard to read, not because you can't see what's happening at the micro level, but because if you wanted to bet your life that you could delete this module and replace it with another one and mirror the behavior completely, or change, let's say, 3 modules, big questions, right? The sweeping architectural rewrites, the ability to do whole system optimization, splitting and refactoring, those are the questions that in normal languages you use tools, you use refactoring tools, you use UML diagrams, architecture diagrams, system maps. You use external documentation to reason about those connections, and then you send somebody to go do the code once you're sure that everything's going to work out. But if you told them all you're allowed to use is your little Java file system hierarchy, and you're not allowed to use the compiler, and now you have to tell me what I need to change where, no search and find, no search and replace, you just have to read the code, they'll look at you like you're crazy. Because the code can't be understood easily at that level. Now, that doesn't mean that it's necessarily bad. It means that they've made a very different design choice in how they're going to approach problems and what they consider important and not. The benefit of APL, one of the design choices, is that these big picture things tend to be easier to deal with in the code level. So macro edit changes on the system graph become more accessible. And so if we prioritize the big picture and make large sweeping edits possible, we get a really interesting possibility. And that is, we can begin optimizing our code base for whole system rewrite. We can begin asking the question reasonably, how do we make it easier to completely delete this code base? And if we can ask that question, suddenly, over time, our technical debt becomes lower, because now it doesn't cost as much to do rewrites. And if we can reduce our technical debt, we have a less chance of leaving old, crufty code sitting around that we're never going to touch, that's inappropriate, that we now have to work around and create less readable code because we're doing the workaround for something that really should be a rewrite, but no, we don't have time for that because it's going to cost too much and we don't really understand whether it's going to work or not. If we have the confidence to think about the macro levels of our program, to make these rewrites and do deletions and all of this other stuff, that can be a huge boon in terms of readability. But that's an aspect of readability people don't deal with. And I think actually that's one of the biggest things. One of the biggest lessons from systems like K or J or these other things is if you focus on the big picture, you can make design decisions that make the little picture irrelevant, or at least much less relevant, because you're optimizing at a better layer. So in conclusion, when we're thinking about this stuff, you just forget everything you ever learned. And instead, what you do is you can focus on specific design principles that allow you to optimize your work with the APL language. And you can think about that as an explicit choice, an explicit spectrum. How much on one side or the other are you going to go? And to do that, you kind of have to push against prevailing best practices. Now, that doesn't mean that the best practices aren't there for a good reason. There are really good reasons to know about those best practices. So you have to make an informed decision about when and where and how to make the decisions. But you can appreciate that arc of possibility and make a decision there that optimizes for your particular context and your particular situation. And so some of the difficulty with this APL wall is that people don't realize that they have to think about these in order to get to that good code. People think that they get to that good code the same way they got to the pretty Haskell code. And you get to the pretty Haskell code in a different way than you get to the pretty APL code. mentally. So this doesn't necessarily make APL easier to learn, but by becoming more aware of the possibilities, you can open up your mind to at least explore other areas that you might have been afraid to explore before, and open up possibilities of doing code reviews in a different way, maybe. A way of introspecting on your process and thinking about whether or not you're really leveraging all the best aspects of APL. Thank you. I got in on time. All right. Barely on time. I don't know if we have time for questions or anything, but if there are any, yeah. Mike?
Okay. Can you please bring up your parser generator page?
Yeah.
We're doing code review.
Sorry?
We're doing code review, right?
Yeah. Let's pull up the parser generator. Oh, no, where are we?
The one page of all APL code.
Yeah. There we go.
Yeah.
Yeah.
It's my pet peeve because if you align the code vertically, it makes it slightly easier for the reader.
Yes. Yeah. I have gone back and forth on that a lot. It's on any given day, you'll see a commit message reformatting all of my code to align vertically, and then another commit message the next day removing it.
Some of it may involve inserting extra blanks.
Yeah. I agree. That's actually a really good point, is that visual layout possibility is something not to ignore, right? You can potentially get some really interesting code regularity benefits in terms of that shape and doing stuff like that, especially if you're working with the train style.
I'm taken with your comments about the computer science world versus, I think this is not, no matter what anybody says. Switch on the mic.
Charge around the right way.
Where? Yeah.
It's certainly not doing anything.
So Aaron, you could.
I'll repeat the question.
Yeah. Okay, so we start out trying to teach APL to people, or trying to teach computer programming to people. What I found is I found it much easier to teach APL to people that are not APLers.
Yes.
In fact, my easiest target audience is artists, and I can talk to an artist and say, well, what are you doing? You know, and I say, well, we're working on array languages. What's an array language? And so I give the example of reduction, and I say, here, we've got this verb and this adverb, and it's just like natural things. Just stick the thing on the left between the things on the right.
Right.
And then I say, okay, now you write, do the same thing, but I want the product of the set of numbers instead of the sum.
Right.
And they think about it for about a second and a half, and they go, how do you write times? You know, like, okay, like this.
Yeah.
And so there's no concept of higher order functions or operators. You know, none of these scare words.
Using the rationalized J-ism vocabulary for describing the
Yeah,
behavior.
well, and sharp APL too.
Yeah.
But I think the point here is that it might be a left brain. Well, I think there's the argument for the pollution of traditional computer science. The question is there also, again, the left brain, right brain thing that comes up from time to time in
Yeah, so there's the question is, there are a lot of different ways of describing APL. There are a lot of different ways of thinking about code. Is there a left brain, right brain, artistic versus analytical division here? And definitely that has to be taken into account, because I've got some friends that they can't program without a good type-directed editing environment that constrains them down to the most minute levels. It's like writing Pascal if Pascal was given an electrode to shoot you every time you made a mistake on the types or something like that. And they linear, down the line, like a CPU, that's how they work with it. But the question about sort of names is an interesting one, because if we talk about using things like the verb-noun association with artists, that makes sense. I specifically use things like function and operand because I can only poke the big bear of computer science so much. That's just too much. I'll be run out of town if I use that. The use of fancy, hard to understand names is more acceptable in computer science than it is to co-opt more natural language terms, even if the more natural language terms are actually a better fit. So that also could apply a little bit in terms of cultural differences when you're teaching or talking about things. Yeah.
It's time for lunch.
It's time for lunch. All right.
Thank you very much.
Thank you.